All right, hi everyone. I think we're ready to get started. Thanks for coming to our session. We're going to be talking about scaffolding data with Tableau Prep today. Is everyone excited for data night out tonight? Yeah? They're bringing back silent disco this year, so personally I'm really excited about that. Yeah, my name is Sasha Singh. I'm a product consultant at Tableau, and I'm based out of our Austin, Texas office.
And I'm Archana Ganeshlingham. I'm a senior product consultant based in our London office.
So just to take a second to introduce ourselves, you might be wondering, based on our accents and being based in different continents, how do we get paired to collaborate on this session together? Archana and I met at boot camp, which is a 2-week training at Tableau. When you start, you get shipped off to Seattle and Washington, where our headquarters are. And I spotted her across the room on the first day, and I was like, she's going to be my friend. I saw her, and I just knew that there was going to be a friendship between us. And over the past 3 years that we've been at Tableau, we talk on the phone pretty much every weekend. We have an annual brunch tradition. We're pretty adorable, but we've also had the opportunity to collaborate in a variety of ways at Tableau. And we're both really enthusiastic about Tableau Prep too. So we have presented workshops, led trainings, built demo content, and presented this session this year, and we also did it last year. And they doubled our room size, so I think we did something right. Here's a few pictures of all of our travels around the world. We've also been to like 5 or 6 different countries together. This is us. We dressed up last year. We forgot our hats this year, unfortunately, but Archana's going to introduce you to the characters that we were dressed up as. Pass it to her.
Thanks, Sasha. So we're going to be framing this session from the perspectives of these 2 characters, and we chose the database Bobby, which is what I like to say in the UK we call our policeman, but that's not really true. No one really says it anymore. And then we have our data wrangler, who's our all-American cowgirl, kind of to fit the both of us. So let's go ahead and meet them. So the database Bobby is a data engineer or database administrator. They know exactly what's stored in the database and specifically how it's been stored in order to optimize for space and query times. While the data wrangler is the advanced analyst with just one thing on her mind, trying to answer the trickiest of questions that the business have. And this session is a Deadeye session, so some of you guys, I hope you guys identify with the data wrangler here. And typically these 2 characters would be butting heads because the data wrangler needs specific structures for their data to be able to answer the questions that the business has. And sometimes she might not have the ability to write the tables that she needs in SQL because the database Bobby doesn't want to give her that access because of all the space and query load she's going to put on the backend system. And so this is where Prep comes in. Prep, we're hoping, is going to be the bridge that will help them cross the ocean of data between them.
So during this session, you're going to become really familiar with the mantra, data stored efficiently isn't always stored effectively for analysis. So if you leave today and don't remember a single other thing that we say, hopefully you take that away with you. We're also going to be going over scaffolding data, so that's definitely a central theme of the session as well, and how you can use scaffold tables to add out your data, and that's what we'll be focusing on the prep side. This is something we added new this year, which is going over unequal joins and how those can help with performance and also help us achieve the same padding effect that's necessary for a lot of the use cases we're going to be going over. And then, of course, we're going to go over how to use Tableau Prep to do all of this. So a lot of what we're going to be showing you today could be achieved in Tableau Desktop, but for the sake of speed, performance, efficiency, we recommend using Tableau Prep for it. Especially with Tableau Prep Conductor being rolled out now, it's something that you can use to schedule and make your whole process more repeatable versus having to do things manually in Tableau Desktop for finding workarounds. So with that, let's hop into our first of 4 use cases. This first one is focused on data from the Spotify Top 200 charts. So this is data that Spotify makes publicly available globally. And we're focusing on a specific song today, No Tears Left to Cry by Ariana Grande. So you might have heard of her, and if you haven't, you were playing her songs as you were walking in, so now you all have. But if you hadn't heard of Ariana, she is a global pop sensation. She has smashed pretty much every record there is to smash as far as singles and charts, her album sales. She's a huge deal, and she makes some great music. We're both huge fans. So this is a line graph showing us how No Tears Left to Cry charted in the Spotify Top 200, pulled directly off the Spotify website. So as you can see, in the beginning of the year, in May, when the song was released in 2018, the song debuted pretty high in the charts, and then as expected, as the year went on, its popularity waned, it went up and down a little bit, but overall it stayed strong. It was charting in the top 200 all year in the US. When we look at this visualization, it doesn't look like the song fell off the chart at all, right? But in reality, it did fall off the chart on just one day in 2018, and that was Christmas Day. And if I had to take a guess, it's probably because Oh, is that better? I'm sorry, guys. My bad. So the song fell off the chart on one day, Christmas Day in 2018, and if I had to guess, it's probably because people switched over to listening to Ariana's Christmas album instead of just her regular music. But the way that the data is formatted right now in this time series, it looks like the song stayed on the chart. It just sort of fell down the chart and then but it stayed within the top 200. So what we'd want the data to look like instead is something more like this, where it's clear where the song fell out of the chart and then came back in. So it's really obvious, how the song charted, and if not, it was in the chart the entire year. So if we look at the way the data is stored, and this is from thinking of the database Bobby's perspective, the most efficient way to store the data, we have a record for every day that the song made it into the chart. And then we have a position number associated with that if the song was in the chart. So we can see here in this slide that on 12/25/2018, the song was not in the chart, and so that record just isn't included at all. There's not even a null associated with it. But the way that we need the data to be stored, the more effective way to store this data from the data wrangler's perspective, is to have a record for the day, even if the song didn't chart, and just have a null position associated with it. And that's going to prevent what we saw in the earlier slides of Tableau just filling in the gap in our data set with a straight line. It can be really misleading, when you apply this to business data rather than just Spotify. But nonetheless, let me hop into Tableau Prep now and show you guys how we can work around this. All right, so I've already pulled in my Spotify top 200 data in here, as well as the data from that we're going to use to scaffold our data set out. So here we have our standard columns that we would expect in our profile pane, and I'm going to go ahead and first start by just filtering down to No Tears, which is the song that we're focused on. So I'll just select people. And the scaffold table that we're using here is just a calendar table. It's an Excel file. Typically, if you have a database you're connecting to, your DBA, your Bobby at your organization probably has a datem table that you can use to accomplish something like this. But essentially all this contains is a record for every day for the date range that we're considering here. So that's January 1st of 2018 to 2019. So I'm just going to go ahead and join these two together. And typically I wouldn't join on a date field, but here that's exactly what we need because we need to create nulls. And I'm going to go ahead and in our join type, go ahead and select a right join. And so you can see in the join summary down here that before we had some data that was being excluded from our scaffold table, and now it's being included in our final join result, which is great. That's the null that we need to account for the days that the song dropped out of the chart. From there, I can just go ahead and add in another clean step, and I'm going to go ahead and remove our original date, and I'm just going to keep our new date. I'll just rename that to date. And from there, all I need to do is output this data. I've already done that for the sake of time, and I brought it into Tableau Desktop. And we can start building out our viz. So we have our new date field that we just created from our scaffold table, and I'm going to start by just bringing that out. And I'm actually going to right-click and drag it and bring it out as a continuous state so that I can see every day in our data set. And then from there, I'm also going to go ahead and bring out position. And so now you can start to see our chart taking shape here. One thing that I had done is just gone ahead and reversed the scale so that we can see when the song was higher up in the chart, and just considering the data we're looking at, that makes a little bit more sense here. I'll go ahead and change the path to a step line. I like that effect for this kind of data just so we can see how it sort of climbed up and down the chart. And then the last and most important thing we need to do here is change the color to Ariana pink. She loves pink, it's a favorite color. And then there we have it. So we can clearly see when the song fell out of the chart. And we also see this 141 nulls indicator at the bottom right. And that's indicating where we scaffolded our data and created those nulls that weren't in the data set natively. Just to show you guys what this is really doing, if I were to filter those nulls out, that gap gets filled in, right? So that's what we were trying to avoid, actually. We can also click in here and show the data at the default position, and that'll kind of show us exactly where those gaps are as well. You know, the song didn't debut until spring, so some of these are blank as well, and then we can see where that gets filled in. But there we have it. Let me switch back to the slides here. Just to recap what we just did, this is a simpler example, but we wanted to start with it just to lay a foundation of what we're going to be going over today. The problem that we were facing in this use case is that we needed to create nulls to account for data that wasn't natively in the data set. And so really the key takeaway for this example is when there's no null and a line item drops out, we can create it by scaffolding and using that datum table. So in the real world, you might see this, say if you worked in retail and you had seasonal retail, so something like a Halloween costume or a Christmas tree, if you're doing time series on that kind of data, right, it would be important to see where that data dropped out and came back in, so you could understand those trends. So that's a sort of a real world application of this one. And with that, I'll pass it over to Tana.
Thank you. Am I on? Yeah? Cool. So a lot of things in our life these days are on a subscriptions basis. So Sasha's already mentioned Spotify, but think about your Amazon Prime, your Netflix, and even Tableau now. And another example is, of course, telecoms. And this data set looks at telecoms contracts, where each row in the data set corresponds to a unique contract ID. So we have information about what product was sold, kind of which bundle, when the contract started, how long that contract lasts for, and then the total contract value. And there's nothing wrong with this data set. That's one of the key takeaways here, is there's nothing wrong with this. You can still do some analysis. I'm sure all of you guys could build these charts in a matter of seconds, answering simple questions like how many of each product did we sell, how many contracts did we sign on this month, or how long do contracts last on average. But we want to bring out the big guns. And when we're looking at contracts data, as a business, it doesn't necessarily matter to us when the contract was signed, the start date. What actually does matter, especially to our finance team, is when we get paid. And this viz shows us just how much revenue we're guaranteed each month based on the contracts we've already signed. So another way to interpret that is that where that line is, October 2019, if we stop selling any more contracts that day, then revenue would stop coming in by early 2021. So we've already secured that revenue for the future. So let's jump back to the data structure and just see what we actually do need then. It's going to be a challenge to create this viz because we have a row per contract. But what we really need is multiple rows for each contract ID, one for each month that a payment is due. So if we focus here on contract ID 1, it lasts for a total of 11 months, for an amount of $333. And so this is how the data should be structured. Essentially a row for every month that a contract lasts for, i.e. its duration. So again, contract ID 1, 11 months, so we have 11 rows. And we'll also look at how we can break down that $330 amount into monthly increments. Oh. Let me go ahead and switch over to Prep. I'll go ahead and clear Sasha's flow from earlier and bring in my contracts example. I'll drag and drop this table in and just use a clean step to show you, again, what the underlying data looks like. I can switch the view state from summary to detail, and that indeed does confirm that we've got one row for every single contract ID. Let me also go ahead and introduce the scaffold table. For this one, for the company that we work for, contracts last for a fixed period. We know that a contract can last for a maximum of 2 years or 24 months. So the scaffold table only needs to be that big. Again, I'll switch the view state to show you what that looks like. We have 24 rows in this data set, numbered from 0 to 23. And this is another key concept, is if you know that the period is a fixed one, unlike Sasha's Spotify example, then your scaffold table doesn't necessarily have to be a date dim table. And we'll come on to that point in another example later on. So what we need to join both of these tables together in what we call a product join or a Cartesian join, and that just means joining every single row from one data set onto every single row from the other, is a common key between the two. And we can just create one in Tableau Prep. I'll call it key, and it just needs to be the number 1, nothing complicated. And I'll do the same in my scaffold table as well. Key and number 1. So that now when I drag and drop to join, Tableau Prep automatically spots that the keys are the common keys. Keys are the common keys. And it's the summary of join results that tells me exactly what's going on. My contracts ID data set starts with 1,000 rows, and my scaffold, as I mentioned, had 4,000 rows. So the join result is going to be a total of 24,000 rows. And again, we can confirm that that has been joined to every single row, because if I zoom in on my contract IDs now, each contract ID has 24 rows associated with it, one for every single row from the scaffold table. So here's where we need to cut that data back down again so that we get the 11 we need. So for that, I can just apply a simple filter. Filter values is up here. So number of months from my scaffold table, I only need it to go as far as the duration of a contract. And I'll hit save. We can see the profile pane update, and I have 11 rows. I wanted to introduce this example with the Cartesian join and then the filtering, just so you can get your head around exactly what's going on when we pad it. But in reality, what we would suggest is using an unequal join. So let me go ahead and introduce that concept as well. So this time I'll bring out my contracts and my scaffold, and what this allows me to do is join on the clause that I applied it in the filter. So here I just drag and drop, again, the 2 tables. There's nothing in common between them, so I need to add my join clause manually. And I just need my duration to be greater than the number of months. This is exactly what I put in the filter step. So this means that we're cutting down the data duplication if we were going to filter it later anyway. And we can confirm exactly what's going on, again with a clean step, switching the view state back over to detail to see that we have 11 rows. The last thing I need to do is create 2 calculated fields. One to give me my payment date, so I'll go ahead and do that. So that's just date add in months, the number of months to my start date. So that gives me my new field, and I'm just going to change the data type to a date. And then the last thing is to distribute that amount, that total contract value, into monthly increments. So that can just be done with amount divided by duration. And hit save. Again, we can go ahead and output this into Prep to build the visualization we were looking for. So here I've already connected to that output. And since this visualization was a little bit simpler than Sasha's one, we don't need to change the axes around and that kind of thing, I just want to show you another handy feature that I use a lot when building visualizations. Now that I'm more familiar with the desktop interface, I can go ahead and pause the auto updates, so that was just up here, and build the visualization, then hit play so that it all loads at once. So then I'm not waiting for queries to run, especially on these larger data sets that get created as a result of the scaffolding. So here, rather than amount, we need to make sure we're using monthly payment on our axes. And again, rather than start date, we want to use payment date. Again, the one from the scaffold. So here I'll right-click drag that so that I can select the monthly level of granularity. We'll break it down by product and then switch it to an area chart. And here's when I hit play, and then boom, just with one click, you get your visualization. Let me jump back to the slides to recap this example. So what did we just do? In this example, to understand when our customers pay, we needed to create a payment date field. So we used the scaffold table to pad out from the start date through the duration of a contract. We learned that when one record needs to be represented by many marks, we need to create those additional records in the data set. And in this case, we join our data to a scaffold table that has as many records as the maximum number of times that a record could need to be represented. So again, just to translate that back to this example, the scaffold table only needed to be 24 rows because we know that's how long a contract can last for at this company. And where else can you use these concepts? Pretty much any kind of subscription-based service where payments are either given or received monthly or annually. So with that, let me hand back over to Sasha for the next example.
Cool. So this next use case is looking at HR data, so headcounts. And the question that we're asking here is, what is our turnover rate? Or another might be, what's our average daily headcount? So the way that this data is typically stored, in a real data set, you'll probably have demographic information as well in the HR department, but the basics of it are we have employee ID, so the ID of the employee at the organization, and then their hire date, so when they started at the company, and if they've left the company, then they have a termination date as well. If they're still at the company, then they just have a null. And so each employee, as you can see under the number of records, just has one record associated with their name, which is a really efficient way to store this from the Bobby's perspective. So before we even get into any scaffolding, kind of like we saw with the contracts example, let's just explore what we can do with this data the way that it is. So in prep, I'm going to go ahead and bring out my headcounts data set, same thing we were just looking at in the slide deck. And I'll go ahead and add a step so I can see what the data looks like. So we've got those 3 columns we're already familiar with. I'll go ahead and add a pivot step here, and I'm going to take the hire date and the termination date and pivot them. And that's going to leave me with 2 new fields, pivot 1 names, which I'm going to go ahead and rename to event type. And then it leaves me with the date field. From there I can go ahead and add another clean step, so you see our new data, the way that it looks. And here I'm going to go ahead and exclude the nulls from date. So we can see that less employees have been terminated, whereas all of them were initially hired. So from here, I just output this data, already have it in desktop. So let's see what we can build out. I'm going to go ahead and bring out my date field. So that's just aggregated at the yearly level. And then I'm going to go ahead and bring out a count distinct of my employee ID. And so I can see my head count over the years if I turn labels on there. If I were to take event type and put it on color, we can also split this out again along hires and terminations. The next thing I'm going to do is go ahead and drag another copy of employee ID onto rows, just so that we have two marks cards to work with and 2 sides of this time series here. I'm also going to go ahead and duplicate my event type field. And what that allows me to do is have 2 legends to play around with, and you'll see why that's important here in a second. So in my bottom marks card that's associated with the bottom part of this time series, I'm going to take that original event type off and put my copy on color instead. And so now this gives me 2 legends to work with as well. I'm going to go ahead and hide the hires and show only my terminations. I don't want to exclude the hires because that would just remove it from the entire viz, but having those 2 event type legends allows me to have some flexibility with what I'm seeing down there at the bottom. I definitely need to keep the hires at the top because a couple things that we're going to do at the top here is add 2 quick table calculations. So first off, I'm going to go ahead and add a running total just so I can see what my running summa is of employees both hired and terminated over the years. And then I'm going to come in here and edit that table calculation. And I'm going to leave that as it is, but I'm going to add a secondary calculation. I'm going to choose difference from, and then I'm going to compute using event type rather than year of date. So I'll choose specific dimensions, event type, at the top, and I'm going to do this relative to the next. And so what that's doing is we saw earlier we had a line for hires and terminations. Since table calculations are view-based, I've made this relative to the next right being. So we're essentially subtracting our hires from our terminations, and it's giving us that yearly head count, taking into account both the people that were hired and then those who left the company. So now if I dual axis these and synchronize my axis here, I have a simple definition of turnover. So I can see in 2017, for example, that we had about a 1 in 7 termination rate with 354 at the top and 51 at the bottom. Okay. So the thing to consider here is the way that we're defining turnover. So in our current definition that we just built out, we are looking at the number of active employees at the end of the year. But let's just say I'm a CEO at an organization, and at the beginning of the year, I have 1,000 employees employed at my company. And then in June, there's a major economic upheaval, something like the Great Recession or Brexit, and I have to lay off 500 employees. At the end of the year, I'd have 500 employees left. And with our current definition of turnover, that would leave me with a 100% turnover rate, which of course isn't accurate. So our current or previous definition of turnover that we just built out isn't considering the head count that we had at the first half of the year, that those 1,000 active employees that we started with. So a better, more accurate definition of turnover would be to look at the terminations divided by our average number of employees that we're left with, and also accounting for those at the daily level, right? So we're getting a little bit more granular here. And that's where we need to join in that calendar table, that date table. So what we need the data to look like is generally the structure is similar as far as we have employee ID, hire date, and termination date. But if you remember from what we saw earlier, each employee had just one record associated with them. And now, so you can see with employee 23, they have over 1,500 records. And that's because that employee worked at the company for that many days, right? So when we scaffold the data out, we have a record for every day that the employee worked at the organization so that we can account for daily headcount and then do something like aggregated to the average, right? Just to give you a simple example to sort of guide you through while I work through on the prep flow, consider if I worked at Tableau for the month of October, I would have 31 records associated. So that's all we're doing here when we scaffold right up. So back in prep, I've got my headcount table that I had earlier, and then I've got my headcount calendar as well. And the first thing we want to do in here is go ahead and create a calculated field. And the reason for that is because when we join our tables together, we need to account for these nulls for the employees that still work at the company and don't have a termination date associated with their employee ID. And so I'm going to use the if null calculation, and I'm going to do this on termination date. So what this calculation is doing, if null will replace any nulls for the field specified with the other thing that you specify. And so here, that other thing is the today function, and today just always returns today's date. And so for anyone in this data set that doesn't have a termination date, their null value will be returned with, what is it, the 14th of November. And I'll go ahead and call this termination date asterisk and save that. And now I can just go ahead and join. So in the past, I'd done this example kind of similar with what we saw with contracts, with doing a Cartesian join and then filtering, but unequal joins are really the more performant way to go about this. So I can just go ahead and use my hire date and join that to my calendar. And then I'll go ahead and also join my new termination date to my calendar. And we're just going to use a less than or equal and then a greater than or equal. And so what that's doing is just trimming any extra rows out. So instead of my, and just to show you guys what the calendar table actually contains, I'll just insert a step here. It has a row for every single day that the company's been around. So all the way from like 1963 to 2019. And so if we were to just join these on each other or use a Cartesian join, if we look at the example earlier of me having only worked with Tableau for the month of October, I would have whatever thousands of rows that are in that date-in table, whereas after we use these unequal joins, I'm left with only 31. So kind of like what we saw with the contracts, just building on top of that, this is paring down our final data set to the appropriate number of scaffolded rows. And from there, I can just go ahead and add another clean step. I'll remove my key field. I don't need that guy anymore. And remove my original termination date as well. And then from there, we just pull this into Tableau Desktop. So already got the data brought in here. And I'm going to start by going ahead and bringing out my calendar table again. And I'll also bring out a count distinct of my employee ID. And so here, this is already sort of mimicking what we saw earlier with the running total, and that's because we've changed the structure of our data. Now I just need to go ahead and create 3 calculations. And the first one is going to be to find our terminations. And so for this, I'm going to go ahead and just use some logic. So I'm going to ask if my termination date equals my calendar date, then I want my employee ID return. And I'll just go ahead and wrap that in a count distinct. And so that's just going to give me a count of my terminations at a row level. The next thing I'm going to do is calculate my average daily headcount. And for this, I'm going to use the include LOD. And the reason I'm using include, I'm going to include at the calendar level. And I'm using the include function here because we're looking at average daily headcount, but our view is aggregated to the yearly level. So now that we have that calendar field and we've scaffolded, we can consider this data at a different level of granularity than we could before. So that's what's going to lead to our more accurate turnover rate. So I've got that include on calendar, and for the tail end of this, I'm going to include on the number of records, right? Because our number of records now represents the number of days that each employee has worked with the organization. So for me, in October, that would be 31. And then I'll just go ahead and wrap this in an average. And then the last thing we need to do is just calculate our accurate turnover rate. And so here I can go ahead and divide my terminations by my average daily headcount. And all we need to do now is go ahead and build out our viz. So I like to bring out terminations and average daily headcount and dual access those. Synchronize these axes so that we have that information readily available too. But then I'll take my accurate turnover rate and actually I'm going to go ahead and change its default properties. I'm going to change the number format to a percentage with no decimal places first. And then I'll go ahead and replace that original count distinct of employee ID. And now we can see that more accurate turnover rate displayed at the top half of this view. I'm going to go ahead and also filter, let's just filter to the last 11 years or so. Because that's where most of the activity happened, most of the hiring and termination. So it's a little easier to see what's really going on. And I'll change this top half to a bar, and there we have it. So now we can see both our average daily headcount, the number of terminations that we had in each year, which is the same as what we were seeing earlier, and then our more accurate turnover rate. So just to recap what we just did, we scaffolded our headcounts data with a calendar date dim table to understand employee tenure and turnover at a daily level. The key takeaway here is when one record needs to be represented by many marks, very similar to what we saw in contracts, that we can create additional records using a scaffold table. And this is helpful when we have business questions that are a little bit more complex than what we originally saw. It's not that we can't work with the data, but when you need to consider your metrics at a daily, monthly, or quarterly level, something that's a little bit more different granularity than that original question, scaffolding allows us to do that. And then finally, you might see this example out in the wild if you, say, work in support and you have open and closed tickets, or if you work in healthcare and you are looking at data around admissions and discharges at a clinic or a hospital.
Small pockets when you're a girl. There you go. So with this example, we're going to be looking at smart home devices. So imagine a home where every device, so the light switches, the washing machine, the TV, the fridge, absolutely everything is being tracked. And this data is stored by device ID. So you have the start and end time for each state that a device could be in. So it could be on, off, cycling, idle, just depends on the device type. And this is how the data's been stored. So when it flips over, you'll notice that the end time of the previous state matches the start time of the next state. So kind of if you read it diagonally, they should match across. And we want to build this visualization where we can see the proportion of time each day that a device spends in each state, so that we can start to spot things like usage patterns and make changes to live a more energy efficient lifestyle. And you guys probably know the drill right now. We're going to need to pad out the data. And here, the problem is that the original data was down to the seconds level of detail. And most organizations will have a date dim table, but I doubt many of you guys have one like a seconds dim or a timestamp dim table, just because it would be huge. It'd be a record for every single second. A quick tip, you can easily create one in Tableau Prep by using the same concepts of scaffolding on a dummy key using those Cartesian joins. So here we do that by joining in an hour, minutes, and seconds table. So these are numbered from 0 to 23 or 0 to 59. And then padding it out with using those dummy key on dummy key joins. That very last step, timestamp, we're just using date add to add those hours, minutes, and seconds to the original calendar. So let's suppose our data wrangler, did that earlier. She came to this session at TC, and she took that key takeaway away. So I'm going to keep referencing this as a timestamp dim calendar, and she used the same concepts explained earlier to do an unequal join, and you can see the join key she used there. So start time is, let me get that right, timestamp is between the start and end time. So that's what the greater than and less thans are doing, so that she can then filter out the redundant records. So she's gone ahead and done that, but that leads to this scenario, where each device, so each row in our original data set, now has a row for every single second that a device was in that state for. So taking that first example, we have 43,445 rows because it was in that state for that many seconds. And when you look at the rest of the data set, our original data only started out at less than 50,000 rows, but this padded data set is over 500 million. Now, this session is about making bonds between our database, Bobby and Wrangler, not creating arguments. And let's take this simple example. The light switch is off between 10:09 p.m.-ish on the 12th of August through to the morning of the 15th. So let's say everyone was away for the weekend. But because of the way the data is now structured, this results in a whopping 200,000 records. So what if I told you that just by writing a few simple calculations, we can cut this down to just 4? Let's take a look. All we have to do is think back to that original question we're trying to answer. Remember, the visualization is only done at a daily level of detail on the rows and columns. So we just need to account for the moments where the state of the light switch spans across multiple days. And that's where our 3 calculations come in. So the first one is duration on the start date. This is going to be a calculation that goes from the start timestamp all the way through to midnight on that very same day. Next is the duration in between. So this is going to be any whole days in between. We add 86,400 seconds. That's the number of seconds in a day. So that would be our 13th and 14th of August. Then finally, we have our calculation duration on the end date. This goes from midnight of the 15th through to 7:38 in the morning when the device was then turned back on again. Oh, I keep giving away the takeaway. So let's take a look how we can build out this kind of structure in Tableau Prep. So let me go ahead and bring in my devices example. So here again, just to show you the underlying data structure, we have my device ID. And if I just focus on one example, we can see that this device ID, the start time and the end times and how they switch between, depending on when someone changed the state of that device. So the thing I need in this data set is a start day rather than a start time, because our calendar table is only at a daily level of detail. So for that, I'm going to go ahead and duplicate this field, start time, rename it to start day, and just switch the data type to a date. And I'll do the same for end time. Then we're ready to go. I can bring in my calendar table, and you can see there from the last example where I have my hours, minutes, and seconds as well. But I'll bring in my calendar table. This is the same as what Sasha showed us with the head counts example. It's just a date dim, so it's just a row for every single day of the year. So we can go ahead and join those two together. Here, the join type we need is so that the dates from our calendar table sit between the start date and the end date. So we want our start date to be less than or equal to the date from our calendar table, and then an additional clause so that the end date is then greater than or equal to the date. So this is very similar to the filter clause that our data wrangler applied in that previous screenshot as well. The difference here is that that one was done at a timestamp level of detail, whereas this one's done at a daily level of detail. And we can see here how we're avoiding that duplication. We have more rows than we started with. So again, if I jump back to the last example, we had 45,000 rows before. Now we only have 51,000 rows. And that also already tells us something. It tells us that most devices stay in a particular state in the same day. It doesn't span across multiple days. So let me go ahead and add in a clean step, so then I can write out the calculations I need to get that seconds level of granularity that I need for my visualizations. So for that, I'll start with a duration calculation, and I've hotkeyed this all in with comments and stuff, just so I can spend some more time talking around it. So the first one is a really simple date diff, just the difference between the start and end time in seconds. This is the foundation for all the calculations going forward, the three that I explained a second ago. Then I'll do my duration on the start date. And it's just going to take a sec to load in. So yeah. Let's fix this. Let me walk you through this one. Here we're saying that if the start and the end timestamp are on the same day, then we just continue to use the duration calculation I just wrote. Whereas if the start and end days are on different days, that means we know that the light switch was on or off or whatever for multiple days. So there we're just going to truncate the calculation. So we just want to go from the start timestamp through to midnight on the same day. And then the last condition is just a 0, and I'll come on to why we need that 0 in a second. So let me go ahead and zoom out and save this one. Then we've got our duration in between. And this is just for any whole days in between. It takes the number 86,400, the number of seconds in a day, and adds that on. So this one's relatively simple. I'll go ahead and save that. So here there's only two possible values, a 0 or 86,400. And then the last thing I need to do is my duration on the end date. This one's a bit more of a monster of a calc. Yeah, so what we do is we put what we want the shortcut to be in. I'm going to talk while we wait for this to go. Put what we want the shortcut to be, and then what the full calculation should be, and then use it for demoing. This is not coming through. There we go. So what this calculation does is it takes, for any state that spanned across multiple days, it would take from midnight of that end day all the way through to when the end timestamp. So this is our 15th of August example. So I'll go ahead and hit save. And then I'm just going to show you the data grid to show you what the underlying structure does. So here, remember that each row now corresponds to the days that a device was in a particular state in. So if you scroll through the data grid, notice how only one of the three values can be filled in. It's either a start date, it's either a whole day in between, or it's an end date. So you'll never have a value, a 0, and then a value. It will always be 0, 0 value. So because of that condition, we now need to combine them into the one column. And this is why we use zeros rather than just leaving them as nulls. Because what that allows us to do is then add across. to give us our total duration. Duration on the start date plus the duration in between plus the duration in the end date. With that one, we're now completed our calculations that we need, so we can go ahead and output into desktop. So here with my devices data set, I can go in and bring my total duration field out. We want to break this down by the date, and remember this is the calendar table date, not the start date or the end date. We want all those dates that we've padded out in between. So we're going in and bring that in at a daily level. I'm going to switch the chart type to a bar so that we're getting closer to our final visualization. I wanted to break this down by device ID so I can analyze, who's leaving the fridge on, or fridge open, I should say, and the light switch on. And then finally, device state is what we want on color. And here, notice that because of the scaffolding, we don't need to use a percent of total table calculation to make sure that the bars are all the same height, because the calculation's already done it for us. So it always adds up to that 86,400. Where the bars are shorter, it's just the end or the beginning of our data set. And with that, let me jump back into the PowerPoint to recap this example. So what did we just do? The viz only needed a daily level of detail, so we can actually use much simpler scaffolding with some filters and some calculations to derive data at a lower level of detail. And we learned that when scaffolding could result in a data explosion, we need to go back to the original question and ask yourself if you really need that granularity in the underlying data, or whether you can manufacture it like we just did using calculations. There are a lot of places where this example has come up in my experience, things like manufacturing with production line effectiveness when machines are on and off, idle, very similar to the smart home example. Facilities management, so if you're planning office space, you can look at how devices, seats, desk space, meeting room space is being used within an office. And then my favorite example is probably the employee time cards one, because if you imagine you clock in and clock out at work every day, and even during breaks as well, but your wages are probably paid on a weekly or monthly basis. So again, this example helps with that.
Remember this time. That brings us to the end of our 4 use cases. And just to recap sort of what we just went over in the past 45 minutes or so, padding out our data with a scaffold or a calendar table is really central to this presentation, the use cases that we went over, because it helps us bridge that gap between efficiency that the Bobby is concerned with, and then efficacy, which is what the data Wrangler is concerned with. And then paired with Tableau Prep's visual and direct interface, all the repeatability and automation that Prep Conductor introduces as well, we can operationalize these processes so that we're not having to manually create joins in Tableau Desktop and repeat over. So like I said at the beginning, if there's one thing that you take away from this session and that we really want to drive home, it's that data stored efficiently is not data stored effectively. We've been looking for a reason to use the quote slide template that our marketing team puts together for the past 3 years, and so we thought we'd just quote ourselves this year. And they were so excited about our sessions, they put it on one of the bubbles, so we're kind of
go take a picture with it.
Here are a couple of other related sessions. I actually am not sure if these are running tomorrow or not. We're kind of coming towards the end of the week, but there's a lot of great prep content that you can explore on the app. And I just wanted to throw out there, I saw some people taking pictures and stuff. All of this content will be provided, and we have notes on all of the flows, so you guys can sort of follow along and if there was anything that you wanted to explore a little bit further. There'll also be a recording of the session posted on YouTube, so you'll be able to find all of this after conference. And then finally, please rate the session in the app. If you loved the session, please give us all 5s, and if you hated it, please give us 5s anyway so that we can continue our cross-continental friendship. Thank you so much. Have a great rest of conference.
Thank you.